We are discussing about GATE 2009 ECE paper, and this question is related to electronics. Consider the following two statements about the internal conditions in an N-channel MOSFET operating in the active region. Statement 1. The inversion charge decreases from source to drain. Statement 2. The channel potential increases from source to drain. Which of the following is correct? A. Both are true. B. Both are false. C. Both are true, but S2 is not reason for S1. D. Both are true and S2 is the reason for S1. The right option for this question is D. So first of all we should know the internal construction of MOSFET and what is meant by active region. N-channel MOSFET always fabricates under P-type substrate. So first we will go with a P-type substrate, and into that one two N plus regions are going to be diffused. One is nothing but this is N plus, the other is one more N plus. One will be acting as source, the other will be acting as drain. So, and over here there is a gate oxide or thin oxide is going to be placed. Gate oxide, or it is also called as thin oxide. This is SiO2 layer, which is called as gate oxide or thin oxide. Above that one there is a polysilicon material is placed. Polysilicon material which is acting as gate. So this is N-channel enhancement mode MOSFET, and it is called as basically off transistor. That is, enhancement mode is called as normally off transistor. Normally off transistor means whenever you are going to apply a voltage across VDS, that is, if you apply a voltage VDS in this manner, by that time this is plus minus. If you apply VDS, there is no current flows from the drain to source. The current flowing through this one is going to be 0 because there is no channel is going to be created. So channel means the area between two N plus regions are going to be treated as this is channel area or channel region. So during this one, at that time it is consisting of P-type substrate only. The channel region now consisting of P-type substrate. So even if you apply a voltage across drain to source, at that time there is no current flows. As this negative terminal, actually what happening is nothing but as the negative terminal is going to be repelling the electrons in N plus, the electrons will move in this direction, so that the electrons will come into this channel region, but the electrons are minority carriers, they will recombine with the majority carriers of holes in P-type substrate. So no electron is going to be reaching the drain. If an electron is going to be reaching drain, then it can be attracted by this positive terminal, so that there is a current flows. But no electron which are coming from the source are going to be reaching the drain, so that no current flows because of applied voltage. That's why it is called as normally off transistor. So to get a current flow at that time, you must get a channel of N type. Channel of N type is nothing but like this. There must be some channel of N type should be created. So this is going to be called as channel of N type, which is going to be called as, in the range it is indicated in this way, N minus. If there is a channel of N type is created, at that time the electrons are passing through that channel, they are not going through the P-type substrate. By that time you will get the current flow. Then it is called as the transistor is becoming on. So this channel, that's why only it is called as enhancement mode, as you are enhancing the channel to get the on operation. So based on the voltage, this channel is going to be created based on the voltage you are applying across gate. So active region is nothing but there must be channel is going to be created, so VGS should be greater than threshold voltage. Threshold voltage VT implies nothing but this is the minimum amount of gate voltage at which channel is induced, channel is enhanced, like this. So VT is the minimum amount of gate voltage at which channel is created, and you can apply more than that one so that a current can flow. So that implies nothing but for the condition channel creation is nothing but VGS minus VT should be greater than 0, and the drain to source voltage VDS is going to be less than VG minus VT. This is the condition for active region, or it is also called as linear region, or the other name is nothing but triode region. So in triode region, the condition is nothing but drain to source voltage has to be less than effective gate voltage, which is VGS minus VT. Okay, so by that time these two statements are going to be given. Inversion charge decreases from source to drain, and channel potential increases from source to drain. Okay, so we will see for this one. This is the diagram. It is for the MOSFET. N MOSFET is in. Now we can say that one NMOS is in triode region. Triode region. Okay, by that time you are applying VDS small. Okay, here it is. By that time we are applying VDS is small, such that it is going to be less than threshold voltage, such that it is less than effective gate voltage VG minus VT. So now we can say that one it is in the triode region. And look at this one, Vs is going to be given with 0 volts and Vd is going to be given. That is actually, strictly speaking, we have applied a voltage in this way. We are applying a voltage in this way. This is VDS is applied. VDS is applied in this way. So whenever VDS is applied, drain is more positive than source. VDS, it is small amount we applied. So source is at 0 volts and drain is at more positive voltage. If you observe, okay, P-type substrate is nothing but this is, okay, source and P-type substrate. Source is of N plus type, substrate is of P-type. So is there a junction is becoming formed or not? PN junction. Similarly, at the drain side, if you are looking at, drain is of N plus type and substrate is of P type. So there is again a PN junction is formed at drain end. So at the drain end there will be a PN junction, and at source end also at a PN junction there is a PN junction. So there are two PN junctions are going to be forming. One is at the source substrate, the other is at the drain substrate. Now, depending on the voltage VDS applied, which source junction, which PN junction will be under which bias, that we will see now. Okay, so as you are applying, source is at 0 and drain is at more positive voltage. For example, you are applying at 2 volts. Okay, you are applying something as 2 volts. By that time, this drain is at, this point is at plus 2 volts and this point is at 0 volts. Okay, so this 2 volts is going to be dropping in the channel itself, because N-type semiconductor is neutral. Every semiconductor is neutral, whether it is extrinsic or intrinsic. So drain and source are going to be of N-type semiconductors, they will be neutral. So total 2 volts are going to be dropping from the channel, dropping in the channel itself. So here you are going to be getting 2 volts and here you will get it as 0 volts. So entire 2 volts is dropping. So that implies nothing but you are applying more positive voltage towards drain side and less positive voltage you are applying towards source side. So if you are going with 0 to 2 volts, in between it is nothing but here you may get it as 1 volt, and over here you may get it as 0.5 volts only. Here you may be assuming that one it is 1.5 volts. So the channel potential, that is channel potential, is going to be increasing from source to drain. So first one we can say that one, the channel potential increases from source to drain. This is channel, entire 2 volts is dropping in the channel and channel potential is going to be increasing as it is moving from source to drain. So at source the channel potential is 0, and as you are moving towards drain side, the voltage channel potential is increasing 0 to 0.5, 1 volt, 1.5, and towards drain it is giving the maximum voltage, that is 2 volts. So first one, channel potential increases from source to drain, that is statement 2. This related to statement 2, which is true. Okay, and next, what about the statement 1? The inversion charge decreases from source to drain. Inversion charge is nothing but charge present in inversion layer. Inversion layer is also called as channel. Channel is nothing but it is called as inversion layer. So channel charge, if you are assuming at that time, since this drain side is going to be, you are giving more positive voltage, by that time drain side PN junction is going to be becoming more reverse bias. Drain side PN junction is more reverse bias, because you are applying drain is more positive. Drain side is more positive is nothing but N side you are applying more positive voltage, even though the source is of N type, but source side you are applying only 0 volts. So drain side PN junction, is more reverse bias than source side junctions. Source side PN junction. Are you understanding this statement? Because drain side you are applying more positive voltage and source side it is 0 volts, so the drain is more reverse bias than source. That implies nothing but more reverse bias towards drain is nothing but more depletion region. More reverse bias means, okay, you can write in this way: more reverse bias means more depletion region. More depletion region is nothing but more depletion width of depletion region is high, and that width of depletion region more penetrates into lightly doped side. That is nothing but substrate is lightly doped compared to drain, so that it will be more penetrated into substrate. This white region is going to be called as depletion region, as it indicates. Okay, I am going with a different color for the this one. So this is depletion region. Depletion region is nothing but this region is going to be called as depletion region. Depletion region consisting of immobile ions, it doesn't consisting of charge carriers, whereas inversion region is nothing but channel area, where it will be consisting of electrons, N minus. So electrons will be present only in channel area, and ions will be present in the depletion region. Ions is nothing but immobile ions, they cannot move. So less number of electrons is going to be at the drain side, more number of electrons will be on the source side. That is nothing but less depletion region at source side, more channel on the source side. More depletion region on drain side, that is nothing but less channel on the drain side, because of more reverse bias towards drain side. So as reverse bias, as VDS increases, we can write like this: as VDS increases, at that time channel area, okay, reduces from source to drain. That implies nothing but the inversion charge is going to be reduces from, okay, inversion charge decreases from source to drain. So this is going to be, this is source side inversion charge, this is drain side inversion charge, which is going to be reducing. So this is related to statement 1. So statement 1 is also true. Okay, and statement 1 is also true, and statement 2 is a reason for statement 1. Both are going to be interrelated. This is related to the linear region, both are interrelated, so that statement both are true and statement 2 is a reason for statement 1. So the right option for this question is D.